Now, dear students, till now we have placed our components as well as drawn our outline of our board. Just let's zoom in to see. This is our board outline, which is in the white color. This is drawn in edge cut layer. So for better visualization, let me show you in 3D view. Go to view, and over here this is 3D viewer. You can see over here these are all our components which we have placed in our board. So let's just click over here so that we can see the components. So this is currently how our PCB is looking. Let me show you over here. This is how our PCB, you can see over here. This is the bottom side, this is the front side. So the next step in layout process is to arrange these components. In general there are several considerations for positioning the footprints. Some footprints may have exact requirements such as connectors, indicators or buttons and switch, and some components may need to be placed according to electrical considerations, like bypass capacitors should be close to the power pins of associated IC, and sensitive analog components should be far from digital interference. So all the components have courtyard, and those courtyard should not intersect with one another. Courtyard actually is the boundary outside the footprint of outside of the footprint that defines the physical placement of the component. Component should be positioned for ease of routing. If you don't have very strict restrictions of placing, like you don't have any connectors or something very sensitive to consider for its electrical parameters, then you can place your component for the ease of routing. Connected components should generally be close to one another and arranged to minimize routing complexity. You should arrange your components in such a way that you can easily draw your tracks. So over here you can see these are the thin lines over here. Let me show you. These are the thin lines that is from R101 pad 1 to this BT101 pad 1. So these thin lines are called retinas. This is useful for determining how best position footprints relative to other footprints. Similarly, this is the thin line that is connecting between the diode and resistor, and from this pad to this pad, these are the thin lines. These are called retinas. So for the purpose of easiness, the only placement goal is to make the routing process as simple as possible. Just for our learning purpose, let me move this battery holder you see over here, BT101. So let me just select this and move it to back of the PCB. You have seen that. Let me again show you in the 3D viewer. You see over here that this is our battery holder, and that is on the front side of the PCB. So let me close this. In order to move this battery holder, first of all you should observe that the pads of this battery holder are in red color, which means that they are in front copper layer. As you can see on the appearance and layer section, that the front copper layer has a red color. So anything that is red over here means that it is in front copper layer. So let's just select this battery 101, and let's hit M to move it little upside over here, and again click to place the battery holder onto our canvas. And once it is selected, you can hit F to flip the PCB. So hit F. Now you can see over here that the pads of the battery has changed its color from red to blue, which means that these pads have been moved towards the bottom copper layer. On the right side you can see that this bottom copper layer has a blue color associated with this layer. So we have moved the battery holder little above and flipped it towards the bottom copper layer. So these PCB layers are viewed from front side of the board, and footprints on the bottom of the board are therefore upside down and appears mirrored. So each PCB layer has a unique color, as you can see in the appearance and layer section. So we have moved this battery holder towards the bottom copper. So again, if you let me show you in the 3D viewer, you will see over here that this is the front copper layer, and you see that there are no pads for the battery holder, but we have as flipped it onto flip board view, and you can see over this is the bottom side of the PCB, and we have flipped our battery holder towards the bottom side. So let me just close this. So now you see over here that these are crossing one another, like this VCC address from VCC pin 1 to R101 pin 1 is crossing the retinous from ground pin to D101 pin. So we don't want to tangle these retinas. For our easiness in the routing, we don't want to tangle these retinas. So let's just place the components in such a way that the retinuses are untangled. So in order to do that, let's select this battery and move it little above, and let's select this resistor R101, hit M, and you can see over here, let me just hit R to rotate it and place it over here. Similarly, let's click this D101, hit M, and move it over here a little bit down over here. Similarly, let's select this, hit M, and you can place over here. So you can see over here now that the retinuses, these thin lines, are now untangled, and now you can easily route these you can easily route your tracks between these components. So let's just save our work, and let's see in the 3D viewer. This is how your PCB will be looking. This is the front side. If you click on see the bottom view, this is our bottom view. So let's just close this, and this is how you arrange your components in your PCB to just make sure that the retinuses are untangled, the components are placed according to your requirement. You have to consider the positioning of the switches indicators in your PCB, and you have also to consider the electrical characteristics of the components, that which component should be placed at which place in your PCB.